Hey, and welcome to the lesson on finding the discriminant. The student objective for this lesson is to use the quadratic formula to predict the outcome of the function's parabola. Essential question: what is a discriminant, and how can we use it to predict the parabola of a quadratic function? Below you'll see the Common Core standard. So first things first, where can we find the discriminant? Well, it's actually right here. It's found in the quadratic formula. It is the number underneath the radical, so the b squared minus 4ac. That is our discriminant. So I'll write that up here. b squared minus 4ac. What that's going to do, it's going to help us by telling us how many real solutions a quadratic function has. And you might be thinking, how can that tell us? Well, why is it in the quadratic formula? That seems odd. Well, the quadratic formula helps us find solutions, so it doesn't make too much crazy sense. But think about it. There's three possible scenarios for this b squared minus 4ac. It could be less than 0. If it's less than 0, well, that means that my square root is going to be a negative number. And remember, when we take the square root of a negative number, it's that number from the square root times I, which means that it's imaginary, or it's not real. So, instead of two real solutions, there are going to be no real solutions. And instead, we will have two imaginary solutions. Now, this b squared minus 4ac, it could also be greater than 0. And in that case, there are two real solutions. Why are there two? Well, because it's added and subtracted from this negative b over 2a. So there's two real solutions. Now I said there were three scenarios. Well, the last scenario is that, in fact, b squared minus 4ac actually equals 0. And in that case, there's only one real solution. And you might be tempted to say that there's one imaginary solution. But remember, you can't have one imaginary solution without its complex conjugate. So there's only one real solution, and in fact, this is possible using multiplicity. So we can also look at this graphically. So if the discriminant is less than 0, and there are in fact no real solutions, therefore two imaginary solutions, then I could have a parabola that looks like this. So if the vertex is above the x-axis and it opens up, then you can see that the parabola will never intersect the x-axis. Therefore, there are no x-intercepts. Or my vertex could be below the x-axis and in fact open down. Therefore, there still would be no x-intercepts. If the discriminant equals 0, if we look at that graphically, that just means that the vertex happens to be on the x-axis. So it also happens to be the x-intercept. So if this is my vertex, I had a parabola that looks like that. My vertex is on the x-intercept, therefore there's only one x-intercept. I could also have a parabola that opens down with the vertex on the x-axis. And last but not least, if it is greater than 0, then you get the more usual scenario of the parabola crossing the x-axis at 2 points, where there are two real solutions, either opening up or opening down. Another cool thing about the discriminant that if you didn't know, and about the quadratic formula really, is that the x equals negative b over 2a, that doesn't just come out of nowhere to say, oh, that happens to be the x value for our vertex. It actually comes from the quadratic formula. I don't know if you ever noticed that. Now, since parabolas are symmetrical, the vertex is the same horizontal, here's the axis of symmetry. The intercepts are going to be the same horizontal distance away from the vertex. So this distance here will be the same as this distance here. And that's why we add and subtract to find the x value for our intercepts. And we're adding and subtracting the same number. Therefore, the distance is the same. It's not exactly the discriminant, but the discriminant plays a huge role in how far the intercepts are horizontally from the vertex. It's actually this whole square root of b squared minus 4ac over 2a. That's the horizontal distance from the vertex to one of the intercepts, both left and right, positive and negative. And here is just a better view of that. If you look, here's your vertex and the axis of symmetry. If you see the vertex, the point for the vertex happens to be 1, negative 4, and turns out that the intercepts are exactly 2 away in the horizontal direction. So this intercept on the right is actually at 3, 0. You can see the difference in x is 2, so from 1 I go over 2 and I get to 3. 1, 2. If I do the same distance to the left, 1, 2, look at that. I get to the other x-intercept, which is negative 1, 0. So in this case, it's 2 away from each other.